Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Sutopo. In this video, I will show you how to determine the enthalpy values of the refrigerant for its process in the vapor compression refrigeration system. Many ways to get the enthalpy value, such as using the pH chart or log pH chart, like this one. You can get the point of enthalpy value for each process after the evaporation, compression, condensation, and expansion. So you need to know the parameter value of the pressure and also the temperature for each balance process. So right here, for examples, so you can get the enthalpy value after you know the value of pressure for the evaporation process at 1.2, and also the temperature. And then after the compression, you know the data, the discharge pressure, and also the temperature of the gas of refrigerant. And also after the condensation, the subcooling liquid condition, and then you have also the condition after the expansion. So then you get all the enthalpy values using the log pH charts like this one. Or maybe you can use a table like this one. Yeah? You can get also the enthalpy values for the every condition. You can use the pressure-based table and also the temperature-based table. So you can see here the saturated liquid enthalpy, the evaporation or mixture condition, and also the saturated vapor condition. In this table, only the condition or the value for saturated condition. Also, the other tables are the superheated, like this one. Superheated tables, all the values for the superheated condition. But in this standard tables of the refrigerant, you cannot get the data about the mixture and also for the any condition that maybe can be provided by these tables. Okay. Another method to get the enthalpy using the online calculator. There's many available in the internet. You can search in Google many online calculator for refrigerant properties. So, some of the online calculator you can see here. You can use this link. Yeah? I think this is a good one. This is also I've used many times, yeah, to get the data, free data, and also this website provides several free data. Quite many data they provided. And also, I think this one is also the good one of the online calculator you can use to get all the properties data of the refrigerant. This website provides many kind of fluids, yeah, including all the refrigerant maybe you need to calculate. Yeah? And then you need the parameter based, you need to input here pressure or temperature or another condition. Yeah? So I think this is a very good one because you can also input many parameters like enthalpy, entropy, and also the vapor quality. Okay, so in this video, I will show you the effective one using software. It's called Danfoss CoolSelector tool. So the software is very useful to provide the data of the enthalpy, especially when you want to get the data for the calculation for your problems of the refrigeration process. So you can Googling Danfoss, because this is a free software provided by Danfoss. Danfoss is a very big company that produce many components of the refrigeration systems. Yeah? So they provide also for the consumer the, the software to simulate design of system refrigeration, but they claim that this is not the reference for the design, but it depends on the people who use this kind of software. So if you have a confidence to use this software, so maybe you can use this also as a reference for your design. So simply you download the software and then install in your PC or laptop. Okay, okay, so I have installed the software in my laptops. So this is the home screen of the software of CoolSelector 2. Yeah? So you can see here many components in the refrigeration that produced by the Danfoss. Yeah? So the benefit of this software simulator or the calculator, you can choose many options of the components, yeah, in the refrigeration system that you want to design, and then directly you can get the performance of the refrigeration system, and then the performance directly you can see in the log pH chart plotted in the chart, and then you can analyze. So today I will not give you the video about the design of the refrigeration system, but simply how to get the enthalpy value for any process problems in the refrigerator compression. Okay, so if I have a problem like this one, so I have a vapor compression refrigeration system using R134A, and I need to calculate several parts here. Then I need to determine first the enthalpy values for its heat balance for its process in the vapor compression. The point number one, the H1, H2 after the compression, the H3 after condensation, and H4 after the expansion process. Okay, so in the evaporation outlet condition, we have a condition or before the compression, the pressure 1.2 bar and minus 15 degrees of Celsius. Okay, then, so we use this kind of software, the Danfoss CoolSelector 2, to get the enthalpy value. Okay, so before we use the Danfoss CoolSelector, I suggest you to setting first the language. Maybe you need to change into Bahasa and also the units. So I prefer using the system international system. So you can click the SI or international, or maybe you prefer British or American. I think it's also no problem. Okay, so for the method to get the enthalpy value, so we have two tools here. The first one is log pH diagram and also the refrigerant calculator. Okay, so let's see the tool, the first tool of log pH diagram. Okay, so Danfoss provides several fluids here, refrigerant that you can choose for your projects. So in this case, for my problems, I'm using refrigerant 134A here. So directly you can see here the log pH chart, and you can see the cursor here. You can see the cursor. So we can get the enthalpy value by put the location of the cursor as you need it for your condition of the evaporation, compression, condensation, and expansion. And then you can get the data in the column below here, in the box column. So the enthalpy, it should be here. Okay. So in this log pH chart, I think this is more or less similar with the like this one. Yeah? The picture of the log pH chart as a result of the scan. Yeah, this is a picture. So you will get a quite big error. Yeah, because yeah, the first one because of the maybe unclear lines of the scan picture, the shrinkage paper, or maybe also unclear data here. And the second one is the reading error. So the reading manually in the Danfoss log pH chart will be also give you several errors. But this log pH chart, actually, this is the tool, the very benefit if you design your vapor compression using Danfoss CoolSelector by select all the components, and then you can choose many options, and then directly the Danfoss CoolSelector give you the analysis and plotted all the chart here. You can get all the heat balance data. That is very useful. But in this video, I won't give you this process of design and analysis. I just show you how to get the enthalpy. So I don't prefer this tool. So let's move to the second tool. This is the refrigerant calculator. So in the refrigerant calculator, you need several non-values or several parameters. In my case, I have a case for the task number 1. For the problems after evaporation, I have the data at 1.2 bar and minus 15 degrees of Celsius. This is the condition of the evaporation or before the compression. Okay, so back to the calculation, the calculator here. So the condition after evaporation, it should be in the condition of superheated vapor of refrigerant, because for R134A at minus 15 degrees of Celsius at 1.2 bar, it should be in superheat condition. So we will use this calculator. So for the refrigerant calculator, we have 3 calculators here. So the first condition after the evaporation, we will use the gas or two-phase calculator. Okay, so we need to input the condition after evaporation at minus 15 degrees of Celsius. So it should be 258 Kelvin, and the pressure is 120,000 Pascal. So you only need to input 2 known values here. Just neglect the density required value here, or maybe you can also delete. Okay, then you click the known values of temperature and also the pressure. Okay, then so you get the enthalpy here, 390.7 kilojoule per kilogram. Okay, so we got the H1 data after the evaporation. So we need to get the enthalpy after the compression at H2 condition at 9 bar and 60 degrees of Celsius. So we need to input also the 2 known values. The first one, the temperature at 60 degrees of Celsius, or same as 333 Kelvin. Yeah? And the condition at 9 bar, it should be 900 1000 Pascal. Okay, then also neglect the density. So you need to treat the two known values, the temperature and also the pressure. So you get the data of enthalpy here at 444.1 kilojoule per kilograms. Then the third condition, after the condensation, the refrigerant and the temperature 27 degrees Celsius. So after the condensation here, the refrigerant should be in the condition of subcooled liquid. Subcooled liquid condition. So back to the calculator, because we only have three calculators here, saturated gas, liquid, and two-phase or gas. We don't have a calculator for subcooled liquid, but to get the enthalpy, we can use the saturated liquid calculator here, because as you see in the log pH chart line diagram here, the temperature line before the saturated liquid line is vertical. So if you get the subcooled liquid here, to get the enthalpy, it is the condition of enthalpy is same with the saturated liquid condition. And so if you have a 27 degrees of Celsius at 9 bar, it should be around here. So you will have a enthalpy here, same as condition at temperature condition at separated liquid line at 27 degrees of Celsius. Okay, back to calculator. So we need to input only one value at 27. It should be 300 Kelvin. 300 Kelvin. Then you just neglect the pressure and density. Then you use the saturated liquid calculator. So the non-value only the temperature. Then you get the enthalpy value at H3 after the condensation, 37.7 liter per kilograms. Okay, then. So for H4 after the expansion, for practical vapor compression, usually the condition of the expansion is in the asymptotic condition rather than the asymptotic. So the condition H4 has equal value with the H3. So you have all the condition here, H1, H2, H3, and H4. So the refrigerant calculator, I think, is very useful and also very complete calculator, because you can also input all the other parameters that may be required for your design, including the enthalpy, and vapor quality. Yeah. For example, if you have a condition after expansion that has several certain condition of mixture, for example, the vapor quality, for example, at 40%, for example, or 0.3 here, 0.3, okay? And then the pressure after the expansion may be changed into 1.5 bar or 150,000 Pascal. Then you can get the certain value of enthalpy. You need to click the two known values here, the vapor quality, the X, and also the pressure. Wait a moment. So yes, this is 0.3. So maybe I need to, this is a kind of error, probably. Okay? So, okay, then back to the task of the problem. So I get all the enthalpy. So in this video, focus mainly, I will show you how to get the enthalpy. So I think the Danfoss calculator is very useful. So you can use this software for any kind of analysis that you want, that you need it for your projects. So I need to clear grid first. So for example, we need another parameters for after expansion 1.3 bar and also 25% condition of the mixture of paper. Yeah? Okay, then so or maybe I need to restart. I need to restart first. Error too many clicks. Yeah? Okay, so need to click the, okay then, yeah, kind of error, too many clicks. So I get the data if you have a parameter input of vapor quality and also pressure or temperature. I think it is very useful calculator. So you can use for your analysis or calculation for your projects. So I think that's all in this video. So I hope you can get benefit using this software. Okay, thank you. See you. Assalamualaikum warahmatullahi wabarakatuh.